right. Are we live? Does that sound right?
Yes, we're live.
Okay, so I think we'll get going for the people online and for the huge crowd that we have here today. It's unbelievable. It's very rewarding to see all these my colleagues come and join. So what I'm going to talk about today, and Aga as well, is a little project called NeuroLibre. So this is the product of a drunken dinner, I think, with Nicolas Stikov, Pierre Bellec, Julie Boyle, and myself. And that was probably about 5 years ago now, if I had to guess correctly, maybe something like that. So 5 years later, we actually have a very interesting product that we would like to, take you through today. So I'll give some opening words about what actually NeuroLibre is, and then Aga will show you directly what can be done. So, what is NeuroLibre? Well, let me start with a little preamble first, and in terms of the motivations of why we came up with this part of open science. So this slide I like. I stole it from JB, who stole it from Marianne, who probably stole it from someone else. But eventually, this publication told a pretty interesting story. The slide is many years old now, but there's such a huge amount of data that's lost in terms of accelerating scientific discovery or doing analysis, and it's in the order of billions of dollars every year. So how can we make that better? One concept as a whole is something called open science. So here's the information in terms of the amount of data loss quantified. But in terms of, open science is something that we have all sorts of initiatives to support, and that's a whole world unto itself. What I'm going to hone in on specifically is the publishing aspects of open science. So here's the current model for publishing in many ways. So people feel like there are issues in terms of, how to get, all the kinds of scientific data out there. So I just enumerated a few points. So right now, publishers tend to control a lot of the agenda. That's okay. Hi back there. But I think there's a push and there's a lot of talk about how to have researchers be more in control of publishing itself, right? So there's ways to do that. There's other issues, like in terms of cost of publishing, that can become a factor in some cases. Accessibility to all parts of the publication is also an issue. So we specifically have focused on data publishing in the last few years. A typical publication is, somebody does some kind of analysis, typically a correlation analysis. You find a nice correlation, maybe it's cure for cancer. You publish it in a paper, something very prestigious like Nature perhaps. And then, but then what about all the data, all the source code, all the way that you actually did your analysis, all the documentation for that is sort of lost. And so our first step was build infrastructure that allows for you to share more of the rest of that data, right? Without the infrastructure, without the tools, that was kind of a pointless argument. So we've built a lot of that exact data, that exact infrastructure. And then one of the key features, which is the very specific point about NeuroLibre, is reproducibility. So reproducibility in science, there was publications that came out over the last few years showing how limited reproducibility was. So our goal here is to actually take that a step further. So this is where NeuroLibre was born. It is a very, like I said, open science is a huge thing. There's so many different aspects to it, from acquisition to processing to analysis to quality control, provenance, standardization, interoperability, you name it. There's so many different parts of it. Publishing is one subdomain, and within publishing, the idea that we have is to have a preprint server for reproducible analysis. So I'll say a few more words about what that actually means, and then we're actually going to show you specifically. So a little more preamble. NeuroLibre was sort of put together with funding from the Canadian Open Neuroscience Platform. It was a component of that. It had funding from in other ways too, like for example, Cancer Computer provided some of the infrastructure. I think the Courtois group funded some of this as well, as did the McGill Center for Integrative Neuroscience. So being a component of the Canadian Open Neuroscience Platform, which is a place where all kinds of data is shared, as well as tools, the next natural step was to actually, find more novel ways to publish data. So these are the guiding principles of what we go by. This is what the infrastructure looks like here, just very quickly. You can see the data publishing side is just one piece of this very complicated workflow, which takes you from data itself to a web portal to storage, even high performance computing aspects, and then of course publishing. So before you get to the point where you actually have a full-fledged publication, it's useful to put together your analysis in a nice structured way. Making things automated is definitely taking advantage of the web, so we considered all of that. Doing it in a standardized and structured way is also a key part of what NeuroLibre does. And this is very quickly just an example of some of the underlying technologies. So Binder is the scheduling or the service layer underneath for NeuroLibre. It handles all the different notebooks. It puts them, it sort of containerizes them and stores them and allows you to run analysis on them. The other layers include things like CBrain, where if you wanted to do any kind of high performance computing, you could, and tie that directly into the notebooks. There's a web portal, which you'll see in a second here in terms of how users can access the publishing platform. And then there's a whole sort of review process that goes on where it's kind of like similar or analogous to the review process of actual publishing. But it's with the preprints, and it is more on the technological level to show that the data and the scripts you have are nicely working. And then there's also a review process where reviewers can show more than just give more than just technical feedback, but also give feedback about the content. And then the ultimate product is a PDF that would be a preprint for whatever you're doing. A couple of quick points. This has many uses because, for example, imagine you're a junior person, a grad student of some kind. You may not always be able to go and publish in Nature right off the bat, right? There's a whole process involved in that. NeuroLibre, having a preprint could actually come in quite handy. There's other use cases too, just in terms of reproducibility, that it makes sense for anyone who's publishing anything to have all this available so you can rerun your analysis later. So there are many different ideas, and I will leave it kind of there. This is one quick example of what it looks like. We have many different submissions already. I would say NeuroLibre is in beta phase, and so this is one example of a submission. Here are some of the kinds of things that are checked. We've already sort of collated this into tabular format, so it is something that is very digital friendly. You can query all this information in a database if you wanted to. So this is kind of what it looks like, and with that, I will pass it on to Aga here, who will actually show you this in action. Again, it's powered by the Canadian Open Neuroscience Platform, Binder, Jupyter, and Jupyter Hub, Jupyter Books, CBrain, and Compute Canada, as well as Cancer Computing for the back end. So go ahead and take us through a little magic carpet ride.
Cool, thank you. I guess, yeah, looks okay. So what I want to do right now is just to show the different components of NeuroLibre, and actually I want to show some repositories. We have a template repository guiding authors through as to how to prepare a NeuroLibre preprint. So our main website is neurolibre.org. And as you can see, we already have two preprints published. Oh, it's not sharing this screen?
Yes, you might need to reshare.
Okay.
using a different window.
Sorry for all the people
Yeah.
online. Just give us a second.
So
So-
then move to your icon in the
Or
bottom.
this thing?
Yes, and then go share again. Oh wait. Oh, you might just stop sharing.
Just close video? Or no, what do you, what should I?
There is a stop sharing here.
Oh, here,
but-
stop sharing.
But it's, yep.
Okay,
So
and
now we
then,
can
And
share
then-
again.
let's try again.
Go to the icon in the corner. And share. Yes.
Okay. And
And
did you want the web browser for everything
yeah,
or the
yeah,
entire
yeah.
screen?
I just need the web browser.
And go ahead.
Okay, sorry for that. So, for example, I'm going to go to this meta-analysis of MRI biomarkers of myelin, and on the landing page of this preprint, first we see a PDF. So the reason we are creating a PDF, of course, first to have a really high-level information about what the actual preprint is, which is the reproducible preprint, as you can see on the right side on this menu. And with this PDF information, we collect the author info, affiliations, your ORCID ID, and if there are some studies they'd like to cite, that's where this is handled. And eventually, when we publish this preprint, DOI is minted for this PDF. But this PDF has other components. As you can see here, under the archive section, we have repository, dataset, Jupyter book, and container. So the ultimate aim to create a reproducible preprint, to create, archive, and publish each one of these components, starting from a GitHub repository. So for example, for this one, when you go to the preprint repository, it's going to take you to the original repo from which this preprint was published and cut version, but the developers or the authors of this repository can keep working on their project after this, because we already have archived the version that is associated with the preprint. And then we have a technical screening process. So here we do not review it for the scientific content, but as long as it's about neuroscience, neuroimaging, we just like to make sure that it will run when we publish it as a preprint. And here it's a long conversation between me and the author and our editorial bot, RoboNeuro. It's a web application helping us create these different components of the notebook. For example, we can say, RoboNeuro generate our NeuroLibre notebook, or RoboNeuro generate this PDF, RoboNeuro archive our data, and then finally, once it's all done, publish the study. And data archive. So if I'll show it later in the repository, but if you have a data that is already published and has a DOI, we put that in a data manifest file. So in that case, we are not going to archive a data that has already been archived, but if you are sharing your data, let's say from your Google Drive account or elsewhere, so we will be archiving it for you on Zenodo. And then finally, when we build a Jupyter book from a collection of Jupyter notebooks or markdown files, so then it eventually becomes an HTML file, and we will archive that tiny website as well on the Zenodo, and that's what is being served when we click this reproducible preprint in here. So it may take some time for it to load. But yeah, this is how it looks like. The interface and the design of this Jupyter book is pretty much up to the user, but here, for example, we have an interactive figure showing different studies. So as this is from a meta-analysis, you can explore each one of the publications and then click the link here, and it can actually take you to the article. And here, for example, you see some code cells responsible for generating a figure. So I guess connection is a bit slow. So these cells are going to collapse once the page is loaded, and we will see an interactive figure. But the cool thing here is that the reproducible, we have a reproducible execution environment. So if you go here, and you'll see a binder button, If you open that, it will connect you to our production server to re-execute content that you see on that page to regenerate the figure, or you can change something and explore the different aspects of the preprint. And yeah, finally, there's a container archive. We create a Docker image and archive it as well. So each one of these components has a separate UI. I can show you one of them. For example, this is a Zenodo archive for the container, and it has all the instructions for you to download it and to run your notebook locally. And it has its own DOI. It's tagged with some of the relevant keywords for Canadian Open Neuroscience Platform and NeuroLibre. And it also says that it has a related identifier, which is the DOI of the preprint, the DOI of the PDF. So they are all linked to each other, all these different components. So if we open this, it should take us back to the NeuroLibre page through doi.org, whatever the DOI is. So yeah, it takes a bit time sometimes to load these pages, so I'll skip that part. But now I'd like to quickly show how to create a NeuroLibre preprint on our template repository. So first there is a paper.md and paper.bib, and in paper.md file we have a tiny YAML metadata where you list the title of your paper, affiliations, names, surnames, and the ORCID ID for each author. And then you give a brief summary, and you can cite some papers and add some figures at your acknowledgements. So this is mainly to capture that information. So this is the static part of the preprint. Then when we go to the content folder, we see a collection of markdown files, notebooks, or misformatted markdown files that has some code cells. And we have two important files here. One of them is the configuration file. Here again we have the title, author, some details about from which interface would like your Jupyter book to be accessed and on which server it is going to be run. In this case, it's binder.compy.cloud, which is our test server. And there is table of contents. Here you just create a simple list of files in the order that you'd like to see them on the Jupyter book. And that's the all configuration files we need for compiling a Jupyter book from a collection of Markdown and Markdown files and Jupyter notebooks. And another folder is Binder. So in this folder, we have the descriptions for our executable runtime and also for our data requirements. So this is using another software developed by NeuroLibre team called Repo2Data. We have a data project name, and we also need a web address or a Zenodo repository or Open Science Framework repository, just doesn't matter. We say that this particular preprint will be working on the data shown in this data requirement.json file. And you can use any of the Binder Hub configuration files to define your runtime. It could be a Docker file, it could be requirements.txt, the requirements.txt, or install.r or Octave dependencies. There are a lot of possibilities if you go and check the documentation on the Binder Hub side. So once we have all these things, we'd like to make sure that before submitting our book, we can actually create a Jupyter book. So we go to Robonero preview service. So it's robonero.herokuapp.com. And here you put the preprint repository. It should be a public repo. It can be on GitHub or GitLab. It's completely up to you. You put the preprint repository address. You can compile it for different branches. And then you need to provide your email address and select one of the two options, whether you'd like to compile your PDF or you'd like to compile a NeuroLibre notebook. So if you select the NeuroLibre notebook option, if your file organization meets the minimum requirements that we specify in our documentation, then it will start first creating that runtime, and then it will start executing each one of your notebooks one by one, and then finally compile the Jupyter book and send you the results in an email. If something fails, it will send the logs explaining why it wasn't able to compile an environment or it wasn't able to compile the preprint. So we are using the same API during the review process, during the technical screening process, to make sure that everything is in place before we move your submission to the production server. So for the documentation, further details, you can go to neurolibre.org and see check out our documentation page. It's really, we try to explain everything for how to prepare a submission and in which languages you can submit something, and many other concerns are actually addressed in here. So yeah, I mean, that's pretty much what I'd like to say about it. And I guess we can have an exclusive deal for our beta release, right? If for the first 10 submissions, I can help in person to create that repository. And because we really would like to have more submissions at this point, because we are also developing this as we go. So it's really close to the beta release, but for different programming languages, we may hit different, edge cases, and it's really good to solve different problems to ensure that we have a better service for future users.
Yeah, and so I guess like if there's a summary of this whole initiative, it's that at the least it pushes for more reproducible science, right? So organizing your data, your scripts, your analysis, documentation, everything in a nicely structured way makes everything you do reproducible. There's no harm in going through this process. We provide the infrastructure so that you can, do all this, resubmit in an automated way. You don't have to worry about the cost of that. It's just provided with various kind donations. And then, the best case for this is that this plugs into all kinds of publishing, journals, like in various journals of whichever kind, that are better equipped to do things like full data publishing. So that could be, there's so many different parts of this tool in terms of what you could leverage, whether it's the visualization or whether it's the preprint PDFs themselves, whether it's notebooks. Notebooks by themselves are a pretty impressive technology that a lot of people are adopting. And so we're kind of creating this mini, pre-publishing ecosystem to handle all of these cases. So whichever one suits you best, you can take that, or you can leverage it as a whole. And I have a feeling there's a tremendous amount of work that is going to come around this and all kinds of interoperability with different systems. So this is NeuroLibre in a nutshell, and I guess we are open for questions from the huge audience we have here in person or all the people online. I'll pass it over to you to curate that.
So if you have questions, you're welcome to come up to the stage to ask it. And if you prefer not to, then we will repeat your question for the audience online. And for everyone online, you can put your question in the chat.
Go ahead.
Is there a microphone? Or
Yeah, you can go right up there to that microphone, and then it's easy.
So I'm very happy this is live, and I guess we didn't make much noise about it, but hopefully people will find out. This is something that I discussed with Aga briefly yesterday, which is that Aperture is struggling with their own publishing workflow. They're using Kotahi, and seems like it's slow to be developed. Now we have this JOS workflow that seems to be doing something similar. Does anybody know the differences with Kotahi? And if not, maybe just a brief explanation of what the JOS publishing workflow does and how it handles reviewers.
So I don't know the differences between Kotahi because I haven't been too closely paying attention to that, but maybe why don't you go ahead and tell us about the JOS workflow because you did that.
Yeah. I mean, it's a combination of two web applications. One of them is, as we see, it's an editorial bot to deal with compiling PDFs and everything, and also to handle some scheduled tasks, such as, for example, if you'd like to remind a reviewer to check that submission again in 2 weeks. So it's capable of doing that kind of tasks. And on the control panel, if you're a technical screener, what?
I don't think they can't hear.
Oh, we moved the mic. Okay.
Oh, I see. Sorry.
Okay. So yeah, it keeps everything in a database, so it has a collection of technical screeners, reviewers, and which screener is assigned to which paper, and it also, keeps track of the processes until the paper is published. So it's a combination of two web applications to publish a simple PDF in that case and to archive those PDFs in a GitHub repository. In our case, we modified it, of course, to handle with NeuroLibre specific cases, but I'm not really familiar with the other publishing workflow platform, but this is quite straightforward. Yeah.
Are there other online questions? Or?
We don't have anyone so far.
Okay, are there any other questions, perhaps?
I have a question.
Yeah, sure.
Go ahead.
Yeah, we have discussed this with Aga yesterday, but I was wondering, and maybe we can talk about it again, how are you planning to handle the comments and reviews that might be posted on this preprint server?
Yeah, that's something that I've been thinking about. So one option is to use the same issue that we had for doing the technical screening, because that repo, even if it's closed, that issue, even when it's closed, it can be reopened to continue that discussion. Or we may think about the third issue, because there are two issues already associated with each one of these publications. One of these is a meta review. So it's either, it could be on GitHub, or we may create a forum linking specific pages for each one of the publications for post-publication discussions about the preprints. So yeah, right now it looks like temporarily we will be using GitHub issues, but in the future it could be a forum or another component that shows up right below the article as you see in bioRxiv. So I guess it's definitely an important aspect. Yeah. Thanks.
All right. Any last questions? Nothing online? Don't be shy online. Okay, well, we'll leave it there, and if anyone has any more questions or future plans, then I'm sure we can collaborate together.
Yeah.
Thank you for your attention.
Thanks.